Hello, everybody. This is Wyatt Gage, your instructor here. I hope you're all doing well. I wanted to take just a few moments and do what I would, I guess, call a mini lecture, a mini lesson, and go over a couple aspects of your assignments for this week. As I've been looking at previews or previous submissions, I've noticed there's kind of a reoccurring trend of questions that are done incorrectly. I want to make sure that you have a clear understanding of what the answer is and why it's that answer, more importantly, so that when you are ready to take the quiz, you'll be more successful, so that you can have a better understanding of what we're learning for the week and all that other stuff. So as you can see here, I've got the two different assignments for the week up, the contrast assignments here on the right, and then the grid assignment here on the left. So you can see there's a couple that are highlighted in blue. Those are the ones I'm going to talk about just because, like I said, I've seen kind of a reoccurring trend of those being wrong, and I want to make sure you have a clear understanding why. So if I've go through this, you still have questions or more clarification, whatever else, please do feel free to reach out to me. So let's look at the contrast assignment first here and read through number one. Which of the following sets of exposure factors would contain the highest energy X-ray beam and best penetrate a given body part? Explain why the choice you've made is the best answer. So obviously there's two parts to this, between A and D, which one is it, and then also the Y part. One thing you want to keep in mind when we talk about penetrability or high energy, the main emphasis of that is going to be your KVP. In this instance, for number one, the mass isn't nearly as important. Back when I think when I was first student or just barely hired on as an RT, I remember going up into the NICU, and I went with a buddy of mine to do an x-ray on a baby, and he had forgotten to adjust. It's funny how I have a friend. You can't see, I've got air quotes. I have a friend who did this. Actually, I don't think it was me. I can't remember for sure. But this friend, he forgot to adjust his KVP and his mass from a chest x-ray or something else. And so typically for a portable kid's chest, we'll use the same technique as we would actually a hand. And for the x-ray machine that we use, it's 52 KVP at 2.5. Well, with him forgetting to change it, it was something along the lines of 95 at 5, 95 at 7 for both techniques. And so when we took the x-ray, it was just way off. When we developed it, it was way off. It penetrated all the way through the baby and all this stuff. And we all joked around that the KVP was so high that it probably x-rayed the people on the bottom floor as opposed to the baby who was right there in front of us. So keep that in mind when we talk about penetration and high energy, that high KVP was the result of us x-raying the person on the bottom floor in the basement, even though that's not entirely true. But one way to think of it that way. So once you have that in mind, take out mass. And so of those KVP factors, which one is going to have the highest penetration? Well, in this case, you know it's either going to be a low KVP or a high KVP. Probably won't be a middle one, so you can get rid of B or C. So it's going to be either A or D. And in this instance, a high KVP will produce higher energy and more penetration. And so you can gather from there that the answer for number one is actually going to be D, because of that high KVP penetration causes it. Now, number two seems to mix people up a little bit as well. Which set of exposure factors in the previous question would reduce greater IR exposure than the other three sets? So here you need to take both into consideration. And so what you want to do in this instance is that get all four technical factors equalized by using the 15% rule, by doubling or halving the mass. And so what you'll see once you do those different doublings and halvings, 50% rules, get them all equal, that the exposure factor, the highest exposure, will actually also be V as well. So be sure that you understand that, and you can understand to be able to explain that too. All right, let's shift over here to the grid assignment, and let's look at number 4 and number 5, because again, this seems to be the one that these two seem to be the most confusing for most people. Number 4 is a good one to work through because it's actually a 3-step process. The other ones are maybe 1 or 2 steps, but we need to take it one step further. So here in number 4, an image was taken at 40-inch SID using 28 mass, 70 kVp, and 5:1 grid ratio. The image was repeated using a 60-inch SID and an 8:1 grid. What should the new mass be? Okay, so you can see there's a number of different factors you need to figure out here. First, the use of a 5:1 grid ratio, and that's being changed for the new exposure. So we need to figure that out, and then we need to figure out what it should be given the new exposure. And so we kind of have to go back to square one or back to ground zero, however you want to say it. So what we want to do is actually take away that 5:1 grid ratio and then add on the 8:1 grid ratio. It's going to be an easier process than jumping from 5:1 to 8:1 without going back to ground zero. Okay, so what you want to do, like I said, is we've got the 5:1 grid ratio. That's going to be the conversion factor of, hopefully at this point you know that the conversion factor for the 5:1 grid is 2. And so you're going to take the mass of 28 and divide that by 2. If you wanted to get a calculator, work that out, whatever else, but you can see that's going to be 14. So now that you've got 14, you can then use the factor to now find out if you add the 8:1 grid ratio. And so to do that, of course, you'll take 14 times whatever the conversion factor for the 8:1 grid ratio is, which is going to be 4. So 14 times 4, that's going to leave us at an X amount for mass. Okay, I don't think I'm going to tell you what that is. No, I'm not. But now that's step 1 and step 2. The third step is you have to do the density maintenance formula or the new mass law, however you want to figure out for this new exposure. So you want to maintain that density at the same time, right? And so the density maintenance formula, having gone through all those different factors, should be an easy plug-in and figure out. So in this instance, you're going to take whatever that answer is from step 2, you're going to multiply that by your new X, and that's going to equal 40 divided by 60 squared on both of them, on both ends. So I'm hoping that's making sense. I'm wondering at this point, maybe I'll try a little annotation and work through it with you down here. So one thing you'll need to learn about me is I'm left-handed, but I use a right-handed mouse. And so when I'm asked to draw using a computer and the mouse, it's awful. So my handwriting is not good to begin with. So bear with me. Hopefully it's at least somewhat legible for you. So let's talk about the first step here at number 4. I just want to make sure you have a clear understanding for it. So that conversion factor is 2, as I talked about. So we're going to take the mass, which is 28 of mass, and you're going to divide that by 2. 28 divided by 2 is going to be 14. Okay? Now that you've got 14 for taking away the 5:1 grid ratio, let's go ahead and add the 8:1 grid ratio there too. So you've got 14. When you add a grid ratio, you're going to multiply it by the conversion factor. The 8:1 conversion factor is going to be 4. 14 times 4 is going to be your new mass up to this point. 56 mass. Okay, so that's step 1. That's step 2. Let's go ahead and see if I can clear this out. So you'll remember that 56 mass is the new one that we're dealing with. Now we're going to do step 3, which is the density maintenance formula. That's going to be your new mass divided by your unsure mass. That's going to equal, I want you to think about the relationship between a density maintenance formula and then squared, of course. Relationship between the density maintenance formula and inverse square law. They are indirectly proportionate, of course. And so you're going to figure this out and come up with your answer. And that will be number 4 for you. So like I said, I hope that helps. Let's go to number 5 real quick. I think people don't know exactly what you need to be doing for number 5. as far as the correct formula. So I just wanted to give that to you. When you're trying to figure out the grid ratio of something, I don't overcomplicate it. Basically, you're going to take the height of the strips divided by the width of the interspace material, okay? So you've got the height of the strips, and you're going to divide that by 0.5 millimeters. And that is going to give you your answer. Okay, so thank you for bearing with me. I hope this was helpful for you. I am going to go ahead and wrap it up now. Again, if you have any questions, need further clarification, feel free to let me know. I hope this will be beneficial for you as we get into the quiz. That's due in a little bit. And of course, it should also help with your assignments for the week too. So thanks everybody. Thanks for bearing with me and my handwriting. I'll talk to you all soon.